Professor Perry Guilford and his amazing team are developing a simple blood test that can diagnose bowel cancer and has many other benefits for cancer patients who are receiving treatment. Hello, Professor Perry. I was fortunate enough to meet Professor Perry when Blair was very sick, and Professor Perry was my regular check-in on giving hope to new technologies being discovered to help treat and help solve cancer, and you've helped many families, but this is pretty exciting technology and could be a real game changer for the New Zealand health system.
What we're trying to do here is get technology which we can take to the community. So we're tired of the capacity to screen for cancer, to test for cancer being at the discretion of someone a long way away. So this will take it out to the community. Hopefully it's going to be affordable, that's our intention, and easily accessed by the entire community. So to us, that's the big driver for what we're trying to achieve, is access for the testing for the whole population.
Do you imagine it being used for people who are feeling symptomatic and concerned, and they can just go to their GP and get this blood test?
Yeah, that's right. So that'll be very good for that. It'll be, because this technique is very specific, it means not very many false positives. It'll be really good for that kind of application. So it's way easier to have simple blood tests and prep for a colonoscopy. And also, the impact on the healthcare system is extraordinary too. I mean, the amount of time and money involved in trying to do a colonoscopy is immense. And as we all know, the system is struggling to cope. And if we can take away a lot of that workload into a simple blood test, which is not needed, it doesn't need to be done in a big hospital, then we're going to be way better off.
Perry, I was wondering if you could introduce us to your team and tell us what everyone does.
Yeah, certainly. So on my right here is Professor Mick Black. So he is in charge of what we call bioinformatics, and Jordan Lima, who is a PhD student who's involved in running the technology, but also trying to better understand the attitudes of the community to this kind of technology.
I've been involved in cancer research for a really long time, and so when the prospect of looking at ctDNA came along, it was a real game changer. No question, this is the right thing to be doing, and it's a fantastic opportunity to really make a difference.
Yeah, so not only could it be used for early diagnostics, it could be used for someone who has already been diagnosed with cancer, and they might be travelling, anywhere between 3 to 5 hours to go to a hospital to get all their tests done.
So it could definitely save people time and money and the distress of having to travel away from their home and their support network. We all really appreciate all the work that you guys are putting into making this technology available to every New Zealander, and I'm definitely excited about it and feel like it's a game changer too.
I'll let Jordan perhaps explain what she's trying to do and what the equipment does.
So I have a patient sample that we've gotten out of a blood sample, and then all we do is, once we've got the sample from someone, and they can just pop into their local clinic, or we'll go around with a wee bus, and then just pop the lid back on.
So someone's blood sample's going into this sequenizer now.
There we go. And then we just pop the lid closed, and the computer does all the work.
That little thing there, the slightly smaller rectangle, that's covered in GPUs, so the same things that kids use for playing video games.
Oh my gosh.
There's a whole bunch of those sitting on top of there, and that's what gives it all the grunt. Also makes it really low power, so that's why you can take them out into in the field.
That's
run them off
the battery. Yeah.
It's just so incredible though when you think of all of the pieces of a colonoscopy, even the admin beforehand and the time. Yeah. This just blows me away that someone could literally just have a blood test. What have we got here?
So what we've got here, so this is what we'll actually see. So we've already put the sample inside of the sequencer here, and it's giving real-time data straight back to our computer. So what we're seeing is each of these little dots represents a little hole that the DNA is going through, and then when the electrical current through that hole changes, it'll tell us exactly what that base is. So I'm from Te Tairāwhiti, from the coast that includes Gisborne. They have a mortality rate that is 12 years younger than the national average, so I'd like to make a difference to that. And growing up, we went home for a lot of funerals for tangi. And so when I decided that I wanted to go to university, I decided that I wanted to do something that would change that. I wanted to make a meaningful difference to the health of my whānau, to like go home and talk to my communities and like stand on the marae and ask them what it is that they want out of their cancer care, and then tell them that I'm actually going to use that information to make some difference and to design a technology that we can bring back to the marae for that early diagnostics of my whānau members. Is just like, it's revolutionary, yeah, and very emotional, I suppose.
It makes me so excited, Jordan, that someone is on this project with such a big heart.
So this would sequence an entire human genome, this little device. And so the first human genome took 10 years and $1 billion. And we can now do it. $3 billion, sorry. And now we can do it on this one here for about $1,000. Wow. By getting this technology established in even the smaller centres, we kind of take the control back to the people in the communities, away from the big hospitals.
So like rural GP practices could have this technology,
totally.
and a nurse could take the patient's blood.
Exactly, yeah. It is really hard work, it's expensive, limited resources for doing it. The hospitals are stretched to do all the colonoscopies they need to do for the screening program. And so if we can do anything to reduce that load, we're making it easier for the government, we're making it easier for the Ministry of Health, and making it way easier for families, communities, especially those in rural areas.
So how much money do you need to make this available
Well,
so we can get this rolled out?
We need about $1 million to kind of to get the research to a point where we can start to push it out into those clinical trials.
Wow, what you guys are doing is so amazing, and I really hope that we can get behind you and help raise enough money to get your research completed and have this out in the community ASAP. Hearing how the technology can be used and how people want it to be used is so inspiring, and I'm sure that me, like others, will really want to contribute to your research and to your project and achieve this outcome of a blood test to diagnose bowel cancer early and actually make that meaningful difference to many people's lives.
Yeah.
Yeah, it's quite incredible when I think about the number of people who contact me who are symptomatic and under the age of 50, and so basically they don't meet the access criteria. And, as the public, we all understand that early diagnosis can lead to better outcomes, with bowel cancer being highly curable.
Yeah.
It's pretty mind-blowing that you guys are creating this.
Yeah, it's really exciting. I mean, we're just trying to remove all those barriers to early diagnosis. If you find it early, as you say, it's great outcomes. If you find it late, poor outcomes. And so we're just trying to get rid of all those barriers which make it hard for people to have an early diagnosis. No one should die of bowel cancer, and this technology will stop that happening.